Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, uh, now I'm going to explain about um, the in-lab task, which is there are three tasks. So, for the task one is we have to design our timer, and our timer is like this. So, we use LPM constant, LPM counter, and 7447. So uh, for the LPM constant, we set the decimal to 9 so that um, the countdown will start at 9 until 0. And we have 4 bit. So there's a 4-bit bus. And the PL is connected to the synchronous load, which is at the LPM counter. LPM counter is used to count down the sequence from 9 to 0, and we have clock, and then we have the output, which is connected to 7447, and 7447 is used to connect with the 7 segment display. So also we have TCO, which is sit out. So if we run timer 2, so the timer 2 looks fine. And now we go for the waveform. So as you can see here, when the PL is activate, the countdown will start from 9 until 0. But if the PL here is at the falling edge of the clock, it will not activate it. So then the numbers will start from 15. Here we set as hexadecimal, so F is 15, and countdown until 0. Okay, so now for the task 2. So task 2 require us to design a one hot equation and one hot circuit based on the state diagram that we already obtained from the week 2 experiment. And this is the equation that we have. And from this equation, we are able to construct a one hot circuit, which is like this. So we have the input L, which is used to change the state. SE1 is sensor front, SE2 is the second sensor. And we have the output S0, S1, S2, and S3. And the T, which is the trigger that we want for the later use in task 3. And if we compile it, it looks successful. So now for the waveform. So for the waveform, as you can see here, the L is set at 80 nanosecond. The period is 80 nanosecond, and the clock is 40 nanosecond, and SE1 will be activated at 160 nanosecond, and another one is before 400 nanosecond, and S2 is activated as before 400 nanosecond. So when you look at the S node, it is 1, and then because the L is active, so it will change the state. And since the SE1 is active, so it will go through the state S2 and then S3 and then back to S1, S0. And when both of the sensors are activated, it will straight away go to S2 and then S3 and then back to S0. And if none of the sensors are activated, so then S2 state will skip S1 state will skip the S2 state, straight away go through to the S3 state and then back to S0. So the trigger should have the same output as input L. Okay, so now for the combination for from both task 1 and task 2. So as you can see here, the T that um, we said earlier from the task 2 is now used to connect with the PL from the timer 2. So when T is 1, the PL can be activated. And the TCO from timer 2 is connected to L. So when we run the compilation, it is successful. And now for the waveform. So for the waveform, here I want to set it to hexadecimal to give a better look. Okay. Now, as you can see here, SE1, SE2 comes from the 1 hot, and then there is a CLK um, for the timer, and here is the num, which is the countdown. So A B C D F G is the 7-segment display for the timer. S0 and S3 is from the 1 hot, and then here is TCO. So when you see here, when the countdown at the 0, the TCO is activated, and then we will reset to 9 until 0 and TCO is activated again. So when TCO is connected to L, so when TCO is activated, you see that the sensor at um, S S0 S1. So now sensor E1 is between 80 to 120. Since the sensor is activated, then the state S1 will go to the S2 and then go to the S3 and then back to S0, which is this one. And here we also can see both of the sensors are activated. So then when both of the sensors are activated at TCO, then the S0 will straight away go to S2 and then S3 and then back to S0. So now no sensors are activated, then the state S1 will skip S2 and straight away go to S3. And that's all from me. Thank you.